In 1942, the world was on the brink of collapse. The Nazis dominated Europe. German submarines sank Allied ships as if they were paper toys. Every week, tons of supplies ended up at the bottom of the ocean. The war seemed lost until America decided to do something that had never been done before: build ships as if they were cars on an assembly line.
To understand what happened, we need to go back in time a bit. When World War II began in 1939, the United States had an old and worn-out merchant fleet. Most ships were over 20 years old. They were slow, small, and completely inadequate to transport the millions of tons of supplies that a world war demanded. And then came the disaster. German submarines, the dreaded U-boats, began hunting Allied ships in the Atlantic. It was a silent massacre. In 1942, the Germans were sinking ships faster than the Allies could build them. Fuel, food, weapons, ammunition, tanks, jeeps, everything ended up at the bottom of the sea. England was being strangled. Without American supplies, Europe would fall completely into Hitler's hands. The Allies needed ships, many ships, and they needed them yesterday. But how could they build hundreds of ships in record time when traditional shipyards took months to complete a single vessel?
The answer came from an unexpected place: England. The British had a simple cargo ship design, based on a blueprint that had existed since 1879. It wasn't beautiful, it wasn't fast, but it was functional and, most importantly, easy to build. When President Roosevelt first saw the plans, he looked at the drawing and said, "This ship will serve us well. It carries a good load, but it's not much to look at, is it? A real ugly duckling." And that's how Liberty ships got their nickname, the ugly ducklings of the war. But that ugly duckling would become the ultimate symbol of American industrial capacity. That simple design would be transformed into the largest shipbuilding program in human history. In total, 18 American shipyards would build 2,710 Liberty ships between 1941 and 1945, an average of 3 ships every 2 days.
Let's get to know this ship from the inside. The Liberty ship was 441 feet long and 56 feet wide. To give you an idea, that's roughly the size of 1.5 football fields. Each ship was made of more than 250,000 different parts, 30,000 main components. And do you know how much steel was needed? Almost 7,000 tons. If you stacked all that steel, you could build a tower taller than a 20-story building. The heart of the ship was a triple expansion steam engine, a gigantic machine weighing 140 tons, over 21 feet long and nearly 19 feet tall. It was an old design from 1900, but it had a crucial advantage. It was simple to manufacture and simple to repair. Any mechanic could understand how it worked. The Liberty ship sailed at 11 knots, or about 13 miles per hour. It wasn't fast, but it made up for it in cargo capacity. Its 5 holds could carry over 9,000 tons. A single Liberty ship could transport 2,840 jeeps, or 440 tanks, or 230 million rounds of ammunition. Now pay attention to this name: Henry J. Kaiser. This man had never built a ship in his life. His experience was in road and dam construction. He had worked on the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam. Massive projects, yes, but none of them floated. When Kaiser said he wanted to build ships, the traditional shipbuilders laughed at him. "This guy knows nothing about ships," they said. "It's going to be a disaster." But Kaiser had something the traditional builders didn't. He thought differently. While the old shipyards had been building ships the same way for decades, Kaiser looked at the automobile industry and asked, "Why can't we build ships the way Henry Ford builds cars?" And that's exactly what he did. Kaiser applied assembly line principles to shipbuilding. He didn't want specialized craftsmen working slowly on every detail. He wanted efficiency, speed, and standardization, and he got it. Kaiser's great revolution was prefabrication. Instead of building the entire ship at the shipyard piece by piece, he divided the ship into large sections that were assembled in different places. Think of it as a giant jigsaw puzzle. In factories scattered across the country, workers produced ship parts. Here, they made double-bottom hull sections. There, they assembled the deckhouses. Somewhere else, they welded the stern frame assembly. And elsewhere, they prepared the entire bow section. These prefabricated sections weighed up to 50 tons each. They were transported by truck or train to the shipyard, where giant cranes lifted them and placed them in position. It was like assembling a plastic model, only on a gigantic scale. And here's the secret. When you prefabricate parts in specialized workshops, the work becomes much easier. Welders could work with parts turned upside down or sideways in the most comfortable position. This is called downhand welding, and a welder in this position produced twice as much work compared to someone welding inside the cramped interior of a ship. Before Liberty ships, ships were assembled with rivets. Thousands and thousands of rivets, small metal bolts that joined the steel plates together. It was noisy, time-consuming work that required a lot of skill. A traditional ship needed about 150,000 rivets, and placing each one took time. Kaiser decided to almost completely abandon rivets and use welding. Welding melted the metal and fused the plates directly, creating an even stronger bond. And most importantly, it was much faster to learn and to do. Each Liberty ship required nearly 50 miles of welding. That's right, 50 miles of molten metal seams joining all parts of the ship. It was an absurd amount of work, but with the new prefabrication techniques and thousands of welders working simultaneously, it was possible. The switch from rivets to welding reduced construction time by 1/3 and decreased the ship's weight by 300 tons. Ships became lighter, cheaper, and could be built by workers with much less experience. Imagine an entire city dedicated to building ships. That's what Kaiser's shipyards were. The Richmond complex in California had 4 enormous shipyards side by side. Before the war, Richmond was a small town of 20,000 inhabitants. In 3 years, the population exploded to over 100,000 people. Inside the shipyard, the chaos was organized. 50-ton cranes moved on rails, carrying entire ship sections. Trucks brought parts from all over the country. Furnaces melted metal. Acetylene torches cut steel plates. Welding sparks flew in all directions. And in the middle of all this, people. 90,000 people working just at the Richmond shipyards. Men, women, white, black, people from all parts of the United States who had migrated in search of work. The shipyard operated 24 hours a day, 7 days a week, divided into 3 8-hour shifts. Let's follow the construction of a Liberty ship from start to finish. Everything began with the keel, the backbone of the ship. A long steel beam was positioned at the bottom of the shipway, the inclined ramp where the ship would be assembled. On the first day, crews positioned the keel and began welding the first double bottom sections. The double bottom is exactly what the name says, 2 layers of steel with a space between them. This gave extra protection to the ship. If the outer hull was pierced, the inner layer would still keep the ship afloat. In the following days, prefabricated hull sections began arriving. Cranes lifted them and positioned them in place. Welders rushed to join the pieces. It was an industrial ballet, with each team knowing exactly what to do and when to do it. The bulkheads, the vertical walls that divided the ship's interior into compartments, were installed next. They provided structural rigidity to the hull and created the 5 cargo holds. Each bulkhead was a prefabricated section, welded in place in a matter of hours. With the bottom and bulkheads in place, the ship began to take shape. Now it was time to raise the sides of the hull. Enormous steel plates, each weighing several tons, were hoisted by cranes and positioned against the structure. Welders worked on scaffolding, joining the plates to each other and to the internal structure. The noise was deafening. The heat from the welding torches was intense. Sparks flew in all directions. Workers wore heavy masks to protect their eyes from the intense light of the weld. Meanwhile, up top, other crews began installing the deck. More prefabricated sections, more welding. The deck was reinforced to support the weight of tanks, trucks, and other heavy equipment that would be transported during the war. By the 6th day of construction, the bulkheads and girders below the second deck were already in place. By the 10th day, the lower deck was nearly complete and the superstructure was beginning to emerge. It was impressive to see a ship take shape so quickly.
The superstructure is the part of the ship that sits above the main deck. This is where the bridge, crew quarters, engine room housing, and funnels were located. On the Liberty ship, this entire section was prefabricated as a single gigantic piece. Imagine a 3-story building being lifted by a crane and placed on top of a ship. That's exactly what happened. The deck house, ready and equipped, was transported through the air and welded directly into place. In a matter of hours, the ship gained its characteristic silhouette. The masts were installed. The cargo booms, which would be used to load and unload the holds, were positioned. The hatches, the large openings that provided access to the holds, received their steel covers. By the 14th day, the main structure was complete. The superstructure was in place. The mast houses and the afterdeck house were installed. The ship already looked like a real ship.
Now came one of the most delicate parts of construction: installing the engine. A Liberty ship's engine was a monstrous machine, 140 tons of cast iron, pistons, valves, and gears. It was over 21 feet long and nearly 19 feet tall. It was a triple expansion steam engine, a design that had existed since 1900. Steam entered 3 cylinders of different sizes, expanding progressively and moving 3 giant pistons. These pistons turned a shaft that in turn turned the ship's propeller. 18 different companies manufactured these engines during the war. And here's the genius detail. All parts were standardized and interchangeable. A piston manufactured in New York fit perfectly into an engine assembled in California. If a part broke in the middle of the ocean, any mechanic could replace it. A worker at the Richmond shipyard invented a revolutionary method for installing the engine. He created a mini prefabrication plant where the precision-cut plates that formed the engine's foundation were cut and assembled in advance. This reduced final installation time by almost 90%.
Then came the most anticipated moment, the launch. With the structure complete and the engine installed, the ship was ready to meet the water for the first time. It was a moment of celebration, of pride, of hope. A sponsor was chosen to christen the ship. Usually it was the wife of some officer, a celebrity, or a worker from the shipyard itself. She held a bottle of champagne tied to a rope. Workers removed the blocks holding the ship on the shipway. Slowly, gravity began to do its work. The hull slid down the grease-coated ramp. The sponsor smashed the bottle against the bow, shouting the ship's name. And then, with a crash and a giant wave, the ship plunged into the water. Applause, cheers, horns, sirens. The ship floated. It was alive, but it still wasn't ready to sail.
After the launch, the ship was towed to an outfitting pier. There, over several weeks, it received the final touches that would transform it into a real ship. Electricians installed miles of wires and cables. Plumbers connected the water, steam, and fuel pipes. Carpenters finished the interiors of the crew quarters. Painters applied the final coats of paint. Navigation equipment was installed on the bridge.
Compasses, radios, communication systems, lifeboats were positioned on their davits. Anti-aircraft guns, because yes, these merchant ships were armed, were mounted on the bow and stern. In total, each Liberty ship required about 592,000 man-hours of labor. It sounds like a lot, but remember, with thousands of workers acting simultaneously, these hours were divided among many people and many shifts.
We cannot tell this story without talking about the women. When men went to war, women took their places in factories and shipyards. At the Richmond shipyards, 1/3 of the 90,000 workers were women. They did everything. They welded, they cut steel plates with acetylene torches, they operated cranes, they worked as electricians, plumbers, painters. They did exactly the same work as men, facing the same dangers. You've probably heard of Rosie the riveter who became the symbol of working women during the war. But at Kaiser shipyards, where welding replaced rivets, they tried to create another character, Wendy the welder. She never became as famous as Rosie, but she represented thousands of real women who built ships with their own hands. One of these women was Bernice Grimes, who prepared welded surfaces at Shipyard 1. Another was Kay Morrison, who started as a tack welder and was promoted to certified journeyman welder. Each of them contributed to victory, one weld at a time. In November 1942, workers at the Richmond shipyard decided to do something extraordinary. They wanted to break the world record for speed in building a ship. And not just break it, they wanted to shatter it. The chosen ship was christened SS Robert E. Peary. The keel was laid, the clock started counting, and then something magical happened. 4 days, 15 hours, 29 minutes. That was the total time between laying the keel and launching the ship into the water. Less than 5 days to build a 441-foot ship. Newspapers across the country ran the story. From Seattle to Boston, people couldn't believe it. The shipyard managers made sure to explain that they weren't just trying to break records. Our main purpose, said manager Clay Bedford, was experimenting with new prefabrication methods. We received hundreds of valuable suggestions and time-saving inventions from our workers. We decided to try them all on one hull and see what would happen.